breakage element from this particular one. Now, the point where you now get a particular one that you won't be able to divide it anymore, we will now call that particular one remaining body a what? An atom. So that is just what that definition is trying to tell us, that an atom is the smallest indivisible particle which undergoes a chemical reaction at a particular period in time. Now, atom comprises of what? 3 different particles. Now, we will now relate. We've now gotten to the particular region where we will have to relate your what? Your electrical charge and your what? Atoms in terms of what? Their structure. So we are now looking at it that, okay, if atom could be the smallest indivisible particles, that can undergo a particular a chemical reaction at a particular time. Now, what is their relation? Now, your atom, if you have to break it down scientifically, atom has been drawn this way. You have something in between which we call your nucleus. Do you understand? So this brings us down to these smallest indivisible particles. We said, okay, it's the smallest indivisible particles that undergoes a chemical reaction. Now, if we are to draw it scientifically or structurally, it goes this way. Now, we have some elements. This particular region is what we call your orbit. Now, this one here is what we call your nucleus. Sorry, this is nucleus. Now, at this nucleus, you now have combination of your proton and neutron. Now, in here we have the proton and the neutron, and at the orbit we have your electron. So, meaning that atom itself are broken down into 3 structures. We have your proton. Remember, we said your proton is what? Positively charged, and we said your neutron is what? Your neutron is what? Is neutrally charged. It does not have any charge. Now, we now have your electron, which is what? Negatively charged. Those are the 3 major classes of what? Atoms. If you are to relate your what? Electrical charge with what? Atomic structure. Now, at this juncture, we now go into the actual masses. You know, for every hypothesis or for every rule or theory that is being stated in sciences, a lot of substantiable evidence are actually being brought up to what? To quantify the discoveries. She understands. Now, when we now talk about a scientist came up and was like, okay, we have an atom. That atom consists of 3 major constituents. Now, which are your proton, your neutron, and your electron. Now, we now later discover that these particular constituents, which remains your electron and proton, all have their own masses. Now, we now start with what? The mass of neutron. The mass of neutron is given as your 1.627 exponential minus 27 kg. That is the actual mass. That is the actual mass of your what? Neutron, which forms the constituent of what? Atom. We now have the next one we have is your what? Is the proton. Proton is given as what? 1.672. Yeah, exactly. 1.672 exponential 27 kg. While your what? Mass of electron is given as 9.1023 exponential minus 27 kg. These are the respective masses of what? Your neutron, which is negatively charged, proton, and your what? Electron. So let's go to production of charges. Now, these charges we've actually broken down as regards your atom. We are being told that neutron is a subdivision of what? An atom. Now, that neutron has its own charge, which is what? Neutral. It doesn't have a charge. It's either neither negative or what? Or positive. Now, as you remember, we said your proton is what? Positively charged. Charge. Now, we now have your electron, which is what? Negatively charged, and we've spoken about their respective masses. Now, let's now see how these particular charges are produced. How do you produce electrical charges in physics? Now, let's start with number 1. The first method of your production of charges is what? Friction. Friction. if you recall from your foundational physics, we were made to understand that friction definitely makes life easier. Friction is just the interaction between two surfaces, which is not always smooth. Meaning that if two surfaces come in contact with each other, if the smoothness of these two surfaces are at high grade, or let me say, when the two surfaces are very much too smooth, you realize that they will slide towards each other. So friction is just the ability for what? Two surfaces to have it's just the restriction, let's put it that way. Restriction of two surfaces when they are in relative motion towards each other. You realize that friction is experienced. What do I mean? If you have a coarse surface like this is a coarse surface, this is a smooth surface. Now this is coarse, this is a coarse surface. Now if you have two coarse surfaces relative to each other, you realize that there will be what? Restriction at that surface. What do I mean? This surface will be having reluctance in movement relative to each other. When you say relative motion is just a kind of motion whereby two bodies move in opposite direction with respect to each other. So when there is a restriction at the point where they meet, this restriction is an inability for them to move easily. That restriction is what we call friction. And friction has helped us a lot in this part of the world, or in every activity. It is friction that will make anybody to stand effectively. It is friction that will make you to drive your car on the road without any accident or whatever, because the surface of the ground and the surface of the tire are not too super smooth with each other. So I just decided to paint this scenario for you to understand what is meant by what the word friction. So another practice that can actually bring about electrical charges is number 2. We have contact. We have contact. Now the third one is what we call your electrostatic induction. Remember we said for electrical charges to be produced, we have friction, contact, and what? Electrostatic induction. Now let's see how all these are actually being broken down. Let's start with the first one. Friction. We've spoken about the actual meaning of what? Friction, if you recall that. But let's bring it back to how the practice of this friction enables what? Electrical charges to be what? Produced. Now let's see this. When an ebonite rod and fork comes together due to friction, ebonite rods get charged. What do we mean? Ebonite rod, if this represents an ebonite rod, now if this represents a fork is just like an animal skin. Do you understand? This is your fork and this is your what? Ebonite rod. Now this fork which represents probably an animal skin, or is just like any insulating object. Now the surface of this fork obviously is not smooth. Now the ebonite surface might be smooth, but if the surface of this rod is not smooth and they actually brought in contact with each other, probably being rubbed towards each other, your ebonite rod eventually will get charged, because your fork here is charged. Now by the time you bring it to your ebonite rod's surface will become charged. So at that junction, you realize that their contact, the friction between them, is now the one producing the electrical charges. Now let's go to the next one, which talks about contact. Now this one is almost of the same meaning with the friction above. But under contact, it says when two metals A and B places on insulating stand, then an external charge body is brought in contact with A. After the separation, A gets charged negatively, while B gets positive charge. What do we mean? We have object A. Please look up. We have object A. This is object A. This is object B. This is A and B. Now, when an external object, which is what? Charge, is being brought together. Now, remember, A and B are what? Closely are in contact with each other. Now, if a third object is being brought closer to them, you realize that this A will become negatively charged. What does that mean? It means that charges are moving off A. Now B automatically becomes positively charged. Now, which means that the contact of what? The third object, which is C, brought about what? The charges of A and B. That's just the breakdown as regards contacts. Now, the next one we'll be looking at, let's just go straight to conductors, insulators, and semiconductors. At this junction, we'll be looking at what is meant by a conductor. What is a conductor in science? What is a conductor? Let's see. What does that? A conductor is said to be any material that fully allows movement of electric charge through it. What do we mean? When you have your object this way, this is a rod. Now, if there is easy flow of what? Electrical charge. When you have an easy flow of either electrical charge or heat particles, that's what we call heat particles or heat molecules. When there are easy flow of these two particular parameters along the surfaces, the internal surfaces of this particular rod, it means that this particular rod is allowing the free flow of heat particles and electrical charges along this particular material. So meaning that that particular rod which allows these two parameters to move freely, it means that that rod is what we will term a conductor. The rod is going to be termed a conductor. Why? Because it allows free movement of both electrical charges and heat particles along freely. Now, let's start with an inductor. Before we go into that, let's go to examples of the conductor. E.g., we have number one, a copper wire. Your copper wire, it will fit straight up into this particular analysis here.